Okay, in this video I'm going to show you how we find sine, cos and tan when we're given two angles inside the right angle triangle and we're asked to find the sine, cos and tan of both angles. Okay, so here's an example. Find the sine, cos and tan for angles A and B, so for two angles. And you'll notice here there's three angles in a triangle, but this is 90 degrees, and they call this one here A, angle A, and this one angle B. And they give us all three sides, so we don't need to use Pythagoras' theorem at all. But okay, so let's start off. Imagine we start with angle A first. If I start with angle A, if I was to jump in and label this triangle, we would agree that 13 is H. Okay, because it's across the right angle. If we're using angle A, the opposite would be the 5, and the adjacent would be 12. Okay, so that's fine. So let's do angle A first. So what we would do next is we would say that the sine of angle A is O over H because of SOHCAHTOA. Don't forget SOHCAHTOA. SOHCAHTOA is our memory aid. So sine of angle A is its opposite divided by its hypotenuse, O over H. And in this particular example, our answer would be, well, let's see, 5 over 13. And cosine of angle A would be side A over side H, which in this case would be 12 over 13. And tan of angle A would be O over A, which is 5 over 12. So that was easy, no problems. However, if we now turn our attention to angle B, can you see a problem? Well, I have to relabel these guys, don't I? Because if B is here, the opposite now will be 12 and the adjacent will be 5. And it would get really, really, really confusing if I went and wrote A here and O here and, so I always think when you have two angles, don't be afraid to draw a new quick sketch of the triangle with just the angle that you are interested in, which is B. You can put in your 5, your 13 and your 12 again. But relabel this diagram. So this is H, but because we're talking about angle B here, this will be O and this will be A. And as long as you draw a fresh sketch, it could be a little tiny cartoon, takes 2 seconds. Once you draw it fresh, you're less likely to make a mistake. Now, what happens now is we get the sine of B is O over H, which in this particular one is 12 over 13. The cosine of angle B is A over H, which in this diagram is 5 over 13. And the tan of angle B is O over A, which in this diagram is 12 over 5. And there we have it. Before I finish off this video, I just want to point out a nice pattern here. Does anybody notice something between angle A and B with their sines and cosses? You can pause the video and think about it, and then unpause it. Did you notice that the sine of angle A is 5/13, and that was the same as the cosine of B? So the sine of this angle is the same as cosine of that angle. They switch places. And vice versa, the sine of B is the same as cos A, 12/13. That's the first thing to notice. That's because A and B are kind of like, if you want to think of it like they're related, they're like first cousins, because A and B must always add up to 90 degrees, because that's 90 and 90 is 180, and there's three angles in a triangle add up to 180. So A and B are like first cousins, and the sine of A will be the same as the cosine of the other angle, and vice versa. What about tan? Do you notice anything with tan? Well, the tan of A is the same as tan B turned upside down. So you just turned a fraction upside down. So for tan A, it was 5/12. For tan B, it was 12 over 5. So the main idea of this video is not about this. It's about just being able to draw the two pictures and write out what sine, cos and tan are for each. And I'm happy if you can do that. However, if you get a chance to think about it, just look at this pattern.